Hi, Mick McQuaid here to help you with R Markdown in Homework 1 of iste780. And the issue is that some of you already know R Markdown, some of you are beginners at R Markdown, so I'm going to sort of acknowledge that some of you know what you're doing already, but I'm basically trying to focus this on beginners. So when you first start RStudio, this is what you get. Um, At least this is what you get in Mac, and in Windows it's slightly different, but something like this. Now, because I've opened it before, I have a lot of tabs here. These are tabs from ISTE 782, a different course, and a tab that's just giving me available packages from a previous command where I got that. And then I also have, in the console, I have some colors here, and this is because I have the package color out running that just makes this colorful, color-coded so that different types of things are of different colors. And I have that in my R profile. And you may not, if you're a beginner, you probably don't have an R profile. If you want color, you can see me and I can give you my R profile, or I can put it on my courses or something so that you can have it too. But anyway, I'm just going to start with the homework 1 here. The very first thing in homework 1 is to open a file. So this is going to be an R Markdown file. So I'm going to go to the File menu, say New File, R Markdown, and it's going to say Untitled. I'm going to call it i.rmd, lowercase I, capital RMD, and the author is not just me. I'm going, most of you are going to be working in pairs, so I'm going to have a partner here. I'll make this a silent partner. And the output, it's very important that you make this PDF, and I know that those of you who have experience with R Markdown have struggled with PDF, so sorry about that. Hopefully it'll be easier this term. Okay, and then that's all I have to do. It's a document. And what happens is RStudio very helpfully creates a file with a bunch of stuff in it, a bunch of setup stuff that I don't really need. I guess actually I'm going to leave this first chunk of code in here, but I'm going to take everything else out because I don't really need this. And for some reason I can't take it out. Here, well, let's see, cut. Okay, there we go. Okay, now the part that I'm going to leave in here is the front matter. That's the part between two dashes. This is just metadata about the document. So it's got the title, it's got the authors, it's got the date. It happens to have the current date and the output format that I required. And I'm going to add a couple of more here because I got error messages before when I did this. So let's see, I'm going to say header includes, and you may not need these. You may not get the error messages that indicated to me to do these. I'll explain what these are when we get to it, when we get to the point where I got the error messages. Okay, so that's all for the front matter. Now I can include chunks of code, and this is a chunk of R code, and I know it's R code because the letter R is here. I could put the word Python here and it would be Python code. And when I run the chunk by pressing the green arrow here, it would run the Python interpreter instead of the R interpreter. And every chunk has to have a unique label. So you can't use setup again. Setup is already used up in this document. I could always change the label. Label doesn't matter. It just has to be unique for each chunk of code. And the chunks of code are delimited by backticks. So there are 3 backticks here and 3 backticks here at the beginning and end. And include equals false just means that I'm not going to show this in the document. It's going to actually run. ops chunk set echo equals true. So I don't know actually what that even means, but let's see what happens if I run it. I'm going to go back to the console, and nothing special happens. I'm just setting an option here, which I frankly can't remember what it means. I think it just means that I'm going to show the contents of all the future code chunks. Now, if you are following the, one thing I should mention before we start about using R. So we're using R for this because the textbook uses R, and the textbook is a classic ISLR, Introduction to Statistical Learning with R. Most data scientists have done this textbook along with the follow-on textbook, Elements of Statistical Learning, or ESLR, which are both free textbooks and which are, as I say, classics. They're common. You should know at least enough R to get through these textbooks. Beyond that, and you should also know, in my opinion, you should know enough R to be able to use ggplot2 and do graphics. Those are the key strengths of R. It's really great for statistical machine learning, and it's really great for graphics. Beyond that, you may want to use Python. Python is an easier language to learn and more popular. But it doesn't have these, these classic textbooks, there's no equivalent in Python of these textbooks, just as there's no equivalent of the textbook R for data science, which I use in iste780. These are classic books that are worth learning from. Okay, now if you're following the homework instructions, the first thing that I ask you to do is to interleave your answers with the question text. So I'm going to go over here to another window that you can't see and copy the question text for part A, which is this. Use the read.csv function to read the data into R. This is, by the way, this is exercise 2.4.8 or 2.4.8 from ISLR. And I'm going to go through the entire exercise. So you can just follow along with this, type this in, turn it in, and get a perfect score if that's all you want to do. I encourage you to do extra stuff. You won't get any, we don't have extra credit, so you won't get extra credit, but it will enhance your toolbox of data science functionality. I'm going to change this a little bit. I'm going to add backticks around this so that when I render this R Markdown document, this will appear in a programming typeface, whereas this stuff will appear in a plain text typeface. And I'm going to do that in general with functions, put backticks around them. And if I put backticks plus R around them, I could actually make these run. So I can, instead of reporting numbers, raw numbers in my text, I can actually use whatever numbers R would generate in the text. Now, what else did I want to say about this before I run it? Use the read CSV function to read the data into R, call the loaded data college. So now we're going to do this. So to do this, we're going to create another chunk. So this is an R chunk, and I'm going to call this part A. And I'm going to put the code in here. So I'm going to call the loaded data college, and I'm going to use the read.csv function, which helpfully RStudio tells me what goes in here. So RStudio is telling me that I need to put a file name in here. And it doesn't really tell me that I need to put the file name in quotes. I can put the file name in single quotes or double quotes. I'm going to say college.csv in single quotes. That is available on my courses, so you can get that and download that. And come to think of it, I have that in a specific directory, so I need to make sure that I'm in that directory. So I'm going to say session, set working directory, choose directory, and I'm going to choose 780 homework 01. And this happens to be the directory that I have this in, so I'm going to choose that. That's also the directory where I want to save my work, by the way. So I'm going to save this file now and see if it saves in that directory. i.rmd in directory 01. Okay, so it's recognized that as the working directory. Okay, so now I'm going to run this chunk. Now, ultimately, what I want to do is render this document and get a PDF, but I want to also render the individual chunks to make sure that they work. So I'm going to render that chunk, and I see, well, I should see the output right here, but I'm not. Why am I not seeing the output here? Oh, I didn't complete this. So now it's a complete chunk. Now I've added the backticks at the end of it. It's a complete chunk. So run current chunk. Okay, good. So now I've read in the college data set. And the next thing that I'm supposed to do, so that's all I think that I'm supposed to do for part A. Let's see. There are other ways to do this, by the way. I could load the ISLR package and load college from there. When I did that before, I got an error message, which I haven't tracked down, so I'm just going to do it in the way that the textbook urges me to. Okay, then comes part B. So I just went back to the textbook. Oops, I didn't copy it correctly. There we go. Look at the data using the fix function. Okay, so I'm going to put backticks around that. We don't really want R to treat this as data. It may be handy to have these names for later, so try the following commands. Okay, so first I'm going to do the fix function, and then I'll do the following commands. So I don't like the fix function. I'm going to call this part B1 because I'm going to show you a part B2 where I do a different approach to showing you some of the data. Okay, so now I've got a complete chunk there so I can run it. And what's going to happen is it's going to open eventually. This is why I don't like it. It's going to open in X windows, and it takes forever to render it. And notice that it's rendering, it's only showing a few of the columns. There are 18 columns here. I can expand this, and it'll render again, and it'll take forever. And each time that I'm dragging this, it's so slow. So you can see that there are a total of 19 columns here. You can tell that because var20 is the first column that's not named. So there are 18 variables for the colleges, and then the college names, which are given as X. And I don't want that. So what I'm going to do, according to, oh, and I have to quit out of this. This is another thing I don't like about fix. I have to quit out of it to give control back to the console. So you may have a different version of fix on your machine. So yours may not open in X windows, so it may not be as inconvenient as this. But on mine, it's a drag. Okay, so as I say, I want to do something a little bit different here. Well, first I have to do what the textbook says. So the textbook says, I should say row names college. So I'm going to assign row names to college, to the college data set. And I'm going to, those row names are going to be column 1. This is shorthand. This square brackets followed by a comma followed by a number is shorthand for that column number. And I can do a shorthand for the row number by putting a row number before the comma and leaving a blank after the comma. Okay, so that gives me the row names for college. And then I want to delete the existing college data set and replace it with one that has one fewer columns. So I want to replace it with, oops, I want square brackets there, with one that removes that. And it also asks me, the textbook also asks me to review this with fix. So I'm going to review it with fix. but I'm going to comment out this first fix because it's a drag. I'm going to comment out the other one too, but let me just run it this way. So what's going to happen when I run the chunk this way is it's going to assign the first column to be the row names, and it's going to remove the first column, so I just have the first column as row names and not as part of the data set. And that's going to turn out to be valuable because we want to do some calculations using the entire set of columns, and we obviously don't want those calculations to happen on a set of names. Okay, so that opened this again, and instead of X here we see row.names, and we have 18 columns of data here. They're actually, I mean, the fix is kind of like a spreadsheet, so it's actually going to show you that these are the first 19 columns, but this is not really part of the data set. If I try to do an operation on the data set now, it'll do an operation just on the 18 columns here. Okay, oh, I put this twice, so let me get rid of that. Okay, now, as I said, I don't like fix very much. So I want to do another, let me just say I don't like. Okay, so I'm going to do another chunk here, and this chunk is going to be part B2, and I'm going to do this in two different ways. So first I'm just going to say head college. Okay, so now that's a complete chunk, so I can run that. And when I say head college, nothing happens. Why is that? Where did head go? I don't know. This is a puzzle to me. Okay, so I'm going to do it. Oh, here it is. It's right below. Okay. So there's the head of the data set. Now, one problem with this is it's running off the screen. So I guess I can look at the other half of it like this. But when I render this to PDF, it's just going to run off the screen. So I don't like just doing head. Head is okay for getting some idea, but what I want to do is use a library, use a package. Let's see if I can remember what this is. Library, this loads the knit.r package from the library. I don't necessarily need this, but I'm going to use it. I'm going to do it this way. You'll find in R that there is more than one way to do everything. So this cable package, for which I need the knit.r package also, this cable package makes nice looking tables like this using using LaTeX or HTML. And I'm going to do format equals LaTeX and book tabs equals T. Now this book tabs equals T is the reason that I had to say use package book tabs before. It couldn't find the book tabs package. Book tabs package just makes tables look better. And then I use the pipe symbol. So this is the ugliest thing about R, I think, is the pipe symbol. In Unix, the pipe symbol is just the vertical bar. In R, the pipe symbol is %, greater than sign, %. And I think they were stuck with that because when that pipe symbol came into existence in R, the vertical bar was already taken up as an OR bar, so it couldn't be used as a pipe. And so here I'm going to put cable styling. LaTeX options. And this is the whole reason for using the cable package, is so that I can do this scale down. So the purpose of this scale down is so that instead of being shown at this size, this will be shown in a really small typeface so it fits on the page. And that's the whole chunk. Okay, so now what I want to do, because this isn't going to do anything if I just render the chunk. I don't think. Let's see what happens. Oh, so it shows me these little things. That's nice. But I don't really care about that. What I want to do is knit. So knit the current document. So this is going to produce the PDF. And you'll notice, so over here is the document, and you can see that it's really tiny typeface. If I zoom in on this, I guess, can I zoom in? No, that's a fine. Oh, here's zoom. If I zoom in on this, I can see the actual details. But the purpose of this was to show you, partly just to show you the process of wait a minute, where did I, oh, here it is. So this was the process. I'm knitting, or rendering as I prefer to call it, the file i.rmd, and as I do this, each part of the document that it goes through sort of registers on the screen. So the label part A, so this is one reason to do labels, so you can debug and see where you have problems. I typically render the document after every chunk so I can see, you know, where the problems are. Some people like to write the whole document and then try to render it, and then they have a lot of error messages from parts of the document they wrote a long time ago, and it's harder to debug. So I've got these chunks. I've got part A, part B, that's I'm 88% through the document, and part B2, and then I'm 100% through the document. And then this tells all the things that are going on here. I discovered an interesting problem. Oh, and by the way, I get all these warning messages. I actually don't know why I'm getting these warning messages. Xcolor is a package that I don't really think I was using in this, so I don't know why I got. Xcolor is used by the cable package, but I didn't actually use any colors here, so I don't know why I got these warning messages. Warning messages, of course, are not as serious as error messages. Warning messages don't stop the compilation process from happening, so the fact that I don't know why isn't that concerning to me. If it were an error message, I would have to track it down, and I would probably Google the error message to see what I can find out about it. But as a warning message, it's not that important. Okay, now, let's see, what did I want to do next? It seems to me there was something I wanted to say here. Oh yeah, about LaTeX. So I discovered, this is not the first time that I've tried to record this video. I discovered previously that I have Tech Live on my computer, and that's one way to, if you have a Mac, that's, in my opinion, the best way to install LaTeX is through Tech Live. And when I tried to knit the document, when I tried to render the document, I got a message saying no tech installation found. And I discovered that the path that I use, so I use the Mac terminal to render LaTeX files, and that works fine. And I use R at the terminal and to render LaTeX files, and that works fine. But RStudio, for some reason, doesn't look at my configuration files. So I had to edit a file called etc path. That's /etc/paths and add the path to my my TechLive installation into that file in order for RStudio to notice it. So that could be useful to you if you choose TechLive. Most of you will probably choose to install TinyTech, which works fine and is much smaller and less burdensome than TechLive. I use TechLive for other things. For example, all my slideshows, all my documentation and stuff is done using LaTeX, so I need more LaTeX functionality than what TinyTech really provides. Okay, so now it's time to go on to the next part here. I don't know quite what's... I'm going to delete this. I don't think I need this. Okay, so I'm going to go on to the next part of the homework assignment. So the next part of the homework assignment is part C. Use the summary function to produce a numerical summary of the data. Oh yeah, here's another one that I'm not crazy about. You might wonder, because I say I'm not crazy about all these things, and yet I am crazy about this textbook. This is a really great textbook. But I don't like this exercise that much. In fact, I think in the great scheme of things, this exercise is really just to familiarize you with some of the details. Summary function is an object-oriented function, so it produces a summary that's appropriate to whatever object you give it. And summary function is often extremely useful. It's the best way, for example, when you're doing linear regression, it's the best way to get a summary of the linear regression model. So it's a great function, but the way that we're going to use it here, kind of a drag, and I'll show you why. So I'm going to introduce another chunk. This is going to be part C. Is this going to be all of part C, or am I going to do more in part C? Oh, part C1. So this is going to be part C1. And here I'm just going to say summary college. So the object that it's being given is a data frame, and that is kind of not the best use of summary in a way. I personally like summary with other types of objects. So I'm going to run this chunk now, and what you should see here is a bunch of gobbledygook. Okay, so here's all the gobbledygook. Yours won't be in color. Yours will just be black and white. But what's happening is you have a column for each variable, and the column is the heading of a summary of that variable. So for private, we can see that there are 212 colleges that are not private. There are 565 colleges that are private. And that's going to become significant to us later, so remember those. Remember that that there are more private colleges than non-private colleges. The number of applications to the college, the average number of applications is 3,002. The largest one, that's probably Harvard or MIT or something, 48,000 applications. The number of acceptances, and here we see again the max number of acceptances, the mean, the median, the first quartile, the third quartile, the minimum, and so on. The enrollment, top 10%. By the way, the textbook has definitions, what I like to call a data dictionary of this file, definitions of each of these, what each one of these means. Some of them aren't really obvious, like SF ratio is student-faculty ratio. That, to me, was not obvious. Okay, so that's the summary function. That's one way of telling what's going on. Another way that I like better, but is problematic here, is the pairs function. So we're going to find the correlation. So I'm going to just delete this. And I'm going to do C2 here. Let me copy this from the text. So throughout this, I ask you to interleave the text from the textbook here. And that's just so you can come, so it's really obvious why you're doing what you're doing. I can come to this in grading it and tell what you're doing. You can come back to this later and tell what you're doing. Part C2 I'll call this. And then here I'm going to say pairs. And isn't that handy? It completed the... So this is just going to give me college columns 1 through 10. So remember, it used to be the case that column 1 was the names, which we obviously don't care about. This, by the way, pairs just gives us scatter plots, scatter plots of the pairs, of all the pairs. And it's going to be a scatter plot matrix, if you know what that is. And is that going to appear here? Yeah, here it is. So this scatter plot matrix in this view is too small to make any sense of. You can sort of tell that there are correlations. So the variables are down the main diagonal. And this is a symmetric scatter plot matrix. So this entire upper diagonal here is a mirror image of the lower diagonal here. And you can tell that, for example, there's a very strong correlation between applications and acceptance. So these two are mirror images of each other. These two are mirror images of each other. These two are mirror images of each other, and so on. And you can see that some of these top 10% and top 25%, there's some correlation between F undergraduate, I don't know what that means, and enroll. Oh, so most of these colleges are mostly undergraduates, so that there's a strong correlation between the number of undergraduates and the number of enrollees. There's less correlation with the graduates. Oh no, that's outstate. Where's the graduates? I don't see graduates on here. Oh, it's inferred from percentage of undergraduates, I guess. Okay, so anyway, this can be a really useful function, but in my opinion, it's more useful if we do it like this. But it's a problem. We can't just do it like this. So let's do it like this. And see, you can see it much more clearly what's going on. And you can see that privates is a two-value function. It's either private or it's not. But the problem is that we have all these variables. We don't know which ones we should run. So we end up running all of them just to get an idea of what's going on. So I really like the pairs function, although it's, you know, it's got its problems too. A lot of times when we most need the pairs function. Now, by the way that I run this on my machine, I always have, or usually for desktop work, I have an external monitor that's high resolution. It's a large 30-inch monitor, and I stretch the plots out to fit over the entire screen. So I can easily read large plots on my screen, but if you're just working from your laptop, that's not going to be possible. If you're just, you know, using your laptop screen, you can't view really large plots. Personally, I think as a data scientist, one of the prerequisites for your job is they should give you a large external monitor because you need to be able to look at large plots. But that's just my opinion, and I'm not buying you a large monitor, so sorry. Okay, so that's part C, part 2. Oh, and I said I was going to do this, and I never did. I said I was going to do this. I never did. So when I render this, let me render it again. Where is that knit function? There we go. So when I render this, oh, what's happening? Is it rendering? Oh, okay, there we go. So when I render this, notice that R Markdown formats this stuff. So I didn't say that I wanted this to be a hanging indent, you know, with all these lines lined up underneath it. I just get that for free with RStudio. But anyway, you can see it it expands this to take up the width of the page, and I can get it, if I zoom in, I can get a better look, but it's still not that great of a look. What happens? Let me just try zooming in here and see what happens. I do get a better look. Oh yeah, I do. Okay, but it's still not that great. Okay, and there are thumbnails. All right, so let's go back to this now. So part 3 is use the plot function. So this homework assignment is incredibly easy for all but the very last item. They pretty much tell you what to do. The last item is going to just say explore more and give your results. That's a little bit harder because you have to think about what constitutes a good exploration, and we'll talk about that in a minute. Okay, so let's go to C3 now. By the way, RStudio lets me emulate my preferred text editor. That didn't work. So I'm emulating the Vim text editor, which is what I use. Use the plot function. I'm going to put backticks around this. Oh, that's what I wanted to show. Yeah, so see, here is an example of where I put backticks around something, so it puts it in like a computery kind of typeface, because that's something that we might enter in to R. So that's the result of putting these backticks around this. It's just, it makes it look more like a computer input. Okay, use the plot function to produce side-by-side box plots. Now this is a little tricky. So I'm going to first show you a wrong way to do this. I'm going to call this, what am I going to call this part? C3. So let me figure out what the wrong way to do this is. Okay, so now here's a little trick. So I can do with college plot and that saves me a tiny bit of typing. So what I've done is I've used the plot function, but normally what I would have to do, here I'm just going to do it, I'm going to show what I normally would have to do. I would go plot college dollar that's normally how I would have to do it. And I've saved myself 2 characters of typing by saying with college, do the plot function. So this is telling me use the data frame college. So there are some cases where using with is going to save you some typing, save you a lot of typing if you have to do enter a lot of the variables in. But in this particular case, it doesn't save much typing. Okay, so I'm going to do that. And this is wrong. So let me just comment that and say wrong. I'm going to redo this in a minute. I'm going to redo it in the right way after I show you the wrong way. Okay. So what's happened here is I didn't get a box plot. See, it says up here, use the plot function to produce side-by-side box plots of outstate versus private. And I didn't get a box plot at all. In fact, what I got was a scatter plot. And private only has 2 variables. There are only two values of private, yes or no. And so it's assigned these 2 numbers, 1 and 0. I mean 1 and 2. And outstate is the outstate tuition. So look at the size of these tuition figures. This is probably RIT here. God, it's a huge amount. No, I didn't just say that, did I? Okay, so now let me do it the right way. So I'm going to reverse the order of these. So I'm going to reverse the order of these and do it again, and this time it's going to give a box plot, side-by-side box plots. And this is really useful. Box plots, side-by-side box plots are extremely useful because if I can draw a line, if I can draw a horizontal line here that doesn't intersect the boxes, then these are really different from each other. It's very often the case that when I do side-by-side box plots, these two boxes sort of line up next to each other. But here they don't at all. So I know there's a significant difference between the out-of-state tuition for private and non-private, between private and out-of-state. Okay, and these are outliers. So these are the center of the box is the median, I think, by default. You can make it the mean, but I think by default it's the median. You can give a lot of options to this command. This is a really basic version of this command. There's also a box plot command, which gives weird boxes, so I'm not going to do that. The box plot command is odd, very odd looking. I personally prefer to use the box plots in ggplot that are available in ggplot instead of the basic plotting functions of R. But when you're just trying to get a quick idea of what's going on, these very simple R functions are useful. When you're doing actual reporting to your boss, you're more likely to want to use something like ggplot so that it looks really nice. Okay, now I'm going to just delete this and go on to part 4. And part 4 is complicated. It's very interesting compared to some of this other stuff. Shouldn't say that. Create a new qualitative variable called elite by binning the top 10% variable. We are going to divide universities into two groups based on whether or not the proportion of students going from the top 10% of their high school classes exceeds 50%. So this is going to give us the elite schools. The elite schools being the ones that only admit people from the top 10% or mostly admit people from the top 10% of their classes. There was a recent scandal in the news you may have seen. Well, when you're watching this, it may not be so recent anymore, but there was a recent scandal in the news about people buying their way into elite colleges. So we have to take some of these statistics with a grain of salt. Okay, there's a bunch of stuff here. This brings up a couple of points. Okay, I'm going to say elite. So first I'm just going to create elite by repeating the word no. And how many times am I going to repeat it? I'm going to say nrow college. So that's going to repeat it. So here after the comma, I want to put a number. And what's going to happen is this function, nrow college, is going to resolve to the number 777 because that happens to be, if I were to just, here, I'll just go to the console here and say nrow college, and you get 777. That's the number of rows in the data set. So here I could have just typed in 777, but data sets change, and it's always better to use functions than hard numbers, or what in IT they typically call magic numbers. So first I create this column of elites. It's just 777 no's. Now I want to change some of those to yeses. So elite college top 10% greater than 50. So that's our criteria. So those entries, the entries where college top 10% is greater than 50, we want to change to yes. So now we're going to have elite is going to be no for most of them, and then there's going to be a small fraction. I've forgotten what the fraction is of elite colleges. And then I'm going to call it a factor. So instead of being a string, so yes and no are just strings right now. I'm going to make this a factor so I can do other functions with it. And then I'm going to say the college data frame is going to have what's in the college. Oops, let me do this. You may notice I'm trying to be more polite about the way that I write R code. One of the R code etiquette rules that they give you is put space around the assignment operator. And by default, I hate putting extra spaces in. I love packing things in. So I'm trying to get in the habit of doing what the lords of etiquette want me to do. So I'm going to create a new data frame called college that's going to be composed of the old data frame plus this one new column. And then I'm going to do a summary of it. And then I'm going to plot elite versus outstate. Do I really want to do this? Okay, so I think this is what the homework specifies that I do for part 4. So I'm just going to do it. And, oh, here we go. Okay, so it gives me a box plot. So there is clearly a difference in the tuition between the elites and the out-of-state tuition for the publics. Some of the elites are publics, but not all of them. Most of them are not. Publics usually are required by law to admit certain fractions of students from within the state. Okay, so, but certain ones like Berkeley are sort of categorized as elite, even though they are subject to state laws. So now we have part 5. Oh, this one is using the histogram function. So I'm going to use the hist function, which produces histograms. And I'm also going to use a deal here. Let me copy and paste this. Oops. I'm going to use the hist function to produce some histograms. And there are going to be so many histograms, I don't want to just use so many pages because each histogram doesn't contain that much information. So I'm going to use this command, par mfrow c22, useful. So what that command is going to do is divide the print window into 4 regions, 2 by 2. 2 rows and 2 columns, so that 4 plots can be made simultaneously. Modifying the arguments to this function will divide the screen another way, so I could make it, 3 rows and 1 column, or however many rows and columns. With the histogram, histograms are such simple graphics that I can make them really small and they're still legible. Okay, so here I'm going to say R part C5 par mf row equals C22, And it's helpfully put in my extra parentheses for me. And then I'm going to do a histogram of a whole bunch of things here. Let's see. I've got, it says a few of the quantitative variables. So what I did here, so I did this before, and I did college dollar expend. That's 6, yeah. PhD, SF ratio. And why do I have PhD and SF ratio again? Okay, well, forget it. I'm just going to do those 4. Yeah, it looks like before I did 6, but 2 of them are exactly the same. So I'm just going to do those 4. So let me put in the backticks that end the chunk. And so I've got, so the college expenditures are skewed to the left. The graduation rate looks somewhat normal. We would have to do a QQ plot to see if this is really normal. PhD is skewed right, and student-faculty ratio is skewed a little bit left. Okay, so those are interesting things to know about. Those are interesting features that we might want to compare with other features. So I think that's one reason why I did these, because in part 6 we might want to investigate these further. Okay, so part 6 says continue exploring the data. So let me put that up here. Continue exploring the data and provide a brief summary of what you discover. So let me show you a way. So I could just plot these. I could plot different ones, and I'm not really crazy about some of the plots that I actually did. So let me do it this way, part C6. So instead, I'm going to say with college table private elite. So I'm curious whether more elite colleges are private than public. So I'm just going to run that. And look at that. They are, it looks to me at a glance like they are. So here's private, no and yes. Here's elite, no and yes. So these are the colleges that are both non-private and non-elite. These are the colleges that are both private and elite. These are the colleges that are elite but not private. So it looks like, at a glance, like there's an overrepresentation here. But we have to be careful about that because we also have fewer public schools than we have, or fewer non-private schools than we have private schools. So let me show you a different way to do this. I'm going to say library gmodels. And again, this is a package you might have to install by saying install.packages gmodels. And it'll install some dependencies. And so here I'm going to do this. I'm going to say with college cross table, and cross table has capitals in it. This is part of the gmodels package. This is going to give me a, so what I've got here is called a contingency table. This is what insurance companies call a contingency table. This is a common way of dividing up variables, like, you know, who's going to die and who needs to pay more for their insurance and stuff like that. But contingency tables are usually done a little more, with a little bit more elaborate stuff in them. So let's look at this more elaborate version. So in this contingency table, It's the same thing that you just looked at, except all you saw before were these four entries, 199, 13, 565. Now you've got a bunch of entries. So these entries are n, that's what you looked at before, plus the chi-square contribution of each cell, plus n divided by the row total, and that's what I'm interested in here. So n divided by the row total here is 6%. N divided by the row total here is 11%. So even though there were more private colleges, there still is overrepresentation. There's still twice the representation, approximately twice the representation, 6% versus 11.5% of private schools in the elite column. And of course, we've also got column totals and table totals, so you can see that there are a total of 777. Now, I think I can enclose this. I'm not actually sure. Let's see. Let me try to enclose this in cable and see if I get a better looking output. I haven't actually done this, so. This could bomb out. So I'm going to try to knit this now. So I've got all of this other stuff that we've done. Oh, well, this isn't very good. Okay, so it didn't bomb out, but it didn't do me any good. So here's the raw output of with college, and you see that we get the same kind of raw output when we do cable, but we also get this nicely formatted but completely messed up table. So cable isn't the best way to do this. Well, let me just insert that there are plenty of other ways to do tables in R Markdown besides cable. So those of you who have done it before have used Xtable, which might have been a better way. Let's just try Xtable here. I can't remember what package I need to. I can't remember what package I need to do here. But let's. Maybe I need the Xtable package. Let's see if it bombs out. So this, okay, error in Xtable, could not find function Xtable. So let me try. I'm thinking there's an Xtable package, but let's see. But it might be capitalized. I don't know. So I'm going to just go over here to Xtable just doesn't. Oh, okay, I see what the problem is here. No applicable method for Xtable applied to an object of class list. So Xtable doesn't work with this. So I could probably do. Let's try. Let's try it this way. I'm going to just get rid of the of that stuff. Oh, I needed that, didn't I? No, I didn't need that. Okay, let's try it. Let's try it that way. If this doesn't work, I'm going to try another thing. I'm not really totally expecting this to work. Okay, now what I'm going to try to do is just table. See what happens. And that worked. Okay, so the lesson here, oh, I didn't put, this is an anomaly with Xtable. Some people don't like Xtable because it has these little gotchas. Like, how would you know to write results equals as is here? It's totally obscure. You really have to read the Xtable manual to use it. Yeah, so what's happening here is that the Xtable package works with a lot of routine R functions. So table is a routine R function that's in the base R package. The authors of Xtable made sure that it worked with it. Cross table, on the other hand, is in this more obscure gmodels package, and so Xtable doesn't necessarily work with it. So this gives rise, there are actually several different table packages besides cable and Xtable for doing different things. And some of them, for some tables that I've generated, I can't find a good package for. So you basically just have to go with the raw output. This looks terrible, by the way. Why does this look bad? See, before this looked okay. I did something different here. Oh, I put in results equals as is. That works for Xtable, but it did not work for this. So I need to put these in different chunks. So let me just do that really quickly. So I'm going to duplicate this. Oops. And here I want to just do this, and here I want to not do that. The chunk labels have to be unique. I can't have the same chunk label in both of these. And I need the results equals as is to use Xtable, but I need to not have it for cross table. So let me knit this again, or render this, and I should get a better looking result. So all this seems like a real pain, I know. But ultimately it gives you, yeah, so this works and this works, although this was broken across pages, which is not ideal. I would rather not have this broken across pages. And I can put in commands to make this only be on one page, or to decrease the font size so that it's really tiny, so that it's all on this page or whatever. And if this were a polished report, that's what I would want to do. So I'm making you do this way because it's a good way to do polished reports. I would never put this in a polished report, by the way. I would never put this this thing here. And I would probably, although I would use pairs for exploratory purposes in a polished report, I would pick the ones that have correlation or an interesting take in correlation. You know, like this one looks curvilinear. So that's going to be interesting. And I would take out the ones that are mostly blobs. Like I wouldn't do, I can't quite read that. But. Room and board. So I would take out room and board because it doesn't correlate to anything else, apparently. Okay, so this is what I want you to do for this homework to get you in practice of using R Markdown. And this course is not so much about polished reports, except for your project. You're going to have to do a polished report in the project you're going to do for this course. The homework assignments, there are 9 homework assignments like this, and then one that's just a discussion in my courses. But for the 9 that are like this, I want you to use R Markdown and just get in practice of using this to create these kind of reports. Okay, so thank you for your attention. I appreciate your patience and forbearance, and I will see you in the next video.